Okay, everybody, here's an interesting question. It says the graph of y equals the log base 5 of x is translated 2 units down, and then a student writes the equation of the transformed image in the form like this. So what's the value of k? Okay, well, let's talk about this. If you translate that 2 units down, what would that look like? Well, that'll be the log base 5 of x minus 2. Now, a student has combined that into a single logarithm. Okay, well, let's think. I could combine this together. If this was a logarithm, it would make sense to combine it because subtraction would become division. I could do that quite easily here. But it's not. Okay, it's not a logarithm. But I could make it a logarithm. Okay, let's just think about this. Remember that a logarithm is an exponent. A logarithm is an exponent. Okay, and so my exponent here, if I wanted to write this as a logarithm, I just got to think about what that 2 would represent. Okay, for a logarithm, okay, for the thing to have a value of 2, what I got to do here, so I'm going to put the log base 5 of x down there, and I'm going to subtract, and I'm going to make this the log base 5. What I got to think is, what is the log base 5 of what? Well, what value here would make this logarithm equal to 2, to this 2 here? And the answer is 25. Basically, I just got to ask myself, 5 to that power of 2 is what? And that's 25 here. Well, now I've got a log base 5 of x, log base 5 of 25. And okay, and please don't get confused by this. This is 2. All I've done, basically all I did was I took the base that I wanted, raised it to that power, and shoved it inside a logarithm with that base. That's it, okay? And so now subtraction becomes division. So I can rewrite this as the log base 5 of x over 25. And if you compare that to their expression here, they're asking for k. Well, in that case here, that means therefore that k must equal 1 over 25th because k is the value that I'm multiplying by k by the x there. And it's got to be that fraction.